After talking about the core concepts of the business strategy, we now look at the accompanying concepts that are necessary for the financial institution to make sure that the business strategy can be well implemented. One of the areas to look at is data analytics. And data analytics is the hot topic for financial institutions for several compelling reasons. Financial institutions have access to an enormous amount of data and are really eager to harness the wealth of this information to gain insights, to make informed decisions and drive growth. Generally speaking, data analytics allows businesses to extract meaningful insights from raw data and helping them to understand customer behavior, market trends, and operational efficiency. There is the expectation that effective use of data will create a competitive edge. As we have identified customer centricity and risk management as key components of the forward-looking, profitable business strategy for financial institutions, data analysis is a core concept to make this business strategy reality. Structuring data analytics in a financial institution requires careful planning, a well-thought-out strategy to ensure that the data is collected, processed, and utilized effectively to drive informed decision-making. In this blog, we provide a comprehensive guide on how to structure data analytics in a financial institution. My name is Christian Rummer and I am the CEO and founding partner of Q-Lana. We have developed a low-code-based open banking, digital lending and asset management platform. Our banking platform is used by multiple financial institutions in lower and middle income countries and by asset managers around the world. In our blog, we will share with you our expertise and ideas about how to organize financial services, how to develop a successful business model for the next decade, and how to manage risks, how to implement all these ideas and concepts at the right speed and sequence. To start setting up a data analytics area, it is necessary to clearly define the objectives and goals. Determine the specific insights you want to gain and how they align with your institution's strategic objectives. Data analytics itself is the process of examining and interpreting vast volumes of data to derive some meaningful insights, patterns, and trends that can help you making informed decisions to improve your overall performance. Data analytics also plays a pivotal role in transforming raw data into valuable information, enabling the institution to derive products, services, and initiatives based on data-driven decisions. This will help optimize operations, enhance customer experience, and manage risks much more effectively for the institution, as well as potentially also provide support for the clients. Now, what are the key components of data analytics? Well, the first part is the data collection. We have to collect the relevant data from various sources. We have to understand which of the data is actually relevant and which sources are viable. This includes statistical data from market participants. For example, it includes balance sheets from your clients, portfolios from the bank, as well as information about certain transactions they have conducted. We need transaction records from payment systems, account details, and other operational metrics. For example, for SMEs, very interesting could be information about inventory, about invoices, and about payroll. External data sources can encompass market data, economic indicators, social media, and industry statistics. Here, specifically, open access to national databases is important. The collection process must ensure that data accuracy, security, and compliance with data privacy regulations. And this is an area that cannot be underestimated because here really regulatory rules are changing and are expanding every year. An important part here is the data cleaning and preparation. Raw data is often messy and may contain errors, inconsistencies, or missing values. And this is something that requires often quite a lot of explanations. Uninformed people assume that once you have data, it is immediately ready to analyze. However, the way how you clean up the data, the way how you identify the corrections to make sure that there is really accurate and reliable data is extremely necessary, is extremely tedious, and requires subject matter expertise. After cleaning, the data is prepared for analysis by organizing it into a structured format suitable for various analysis techniques. This is the point where, for example, you migrate data from a data lake to a data warehouse, you process the respective cleanup processes and make sure that you have the data ready for your data analyst to process. This results then in specific analytics techniques, for example, descriptive analytics. This stage involves the use of basic statistical methods and visualizations to summarize and describe historical data. Descriptive analytics provides an overview of past performance, customer behavior, market trends, and helps the institution to understand the current state of operation and identify patterns that might inform future strategies. It is very clear that as human beings we are very prone to visualization of data. And you can do your own experiments and see that it is much easier to understand data structures and patterns in a visualization than by looking at the raw data. Going into detail about this descriptive analysis would be in excess of this block, so therefore we stay here with the pure definition of that part. The next part is diagnostics analysis. Diagnostic analysis delves deeper into the data to uncover reasons behind specific outcomes or trends. This involves root cause analysis and identification of factors influencing business performance. For a financial institution, the diagnostic analysis can shed light on factors contributing to the fluctuation of revenues, customer churn, or fraud incidents. So here you go beyond the initial analysis of data, you try to find relationships and you try to build connections to understand specific patterns. Another category is the predictive analysis. In this predictive analysis, you use historical data, statistical algorithms to forecast future trends, events, and behaviors. By analyzing patterns from the past, financial institutions can make informed predictions about customer preferences, investment opportunities, and potential risks. So here you basically take the past data and try to develop extrapolations or other methodologies to really see specific trends, recognizing, of course, always that most of the time we assume that the past can predict the future, which might be true in most cases, but obviously not always. These insights that you gain here will help with strategic planning and decision making. Finally, the prescriptive analysis takes the data analytics to the next level by recommending actions or strategies to optimize outcome. It combines insights from descriptive diagnostic and predictive analytics to suggest the best course of action. For financial institutions, prescriptive analysis can aid in portfolio optimization, fraud prevention, and personalized customer offerings. If we do all this well, data analytics can support in many areas. Here are some examples. It can help us in informed decision making. It empowers to make well-informed, data-driven decisions, reducing the reliance on intuition and guesswork. Of course, we always have a good feeling, and always we need to make sure that we rely on we refer to our intuition as well, but it's always good to make sure that you can base your decisions on specific data. It also helps in risk management by analyzing historical data and identifying patterns, which helps the institution to better assess and mitigate risks such as credit risks, market risks, and operational risks. It gives customer insights because it helps in understanding the preference of market participants, behaviors, needs, enabling the creation of personalized products and services. It helps in the process optimization by analyzing internal operations. Data analytics can identify inefficiencies and bottlenecks, leading to process optimizations and cost reduction. Of course, it also helps with compliance and fraud detection. Data analytics aids in the identifying anomalies and potentially fraudulent activities, ensuring compliance with regulations, safeguarding against financial crimes. It obviously helps also for innovation and new opportunities because you analyze your market trends, you analyze the emerging technologies, and with this, as a financial institution, you can identify new opportunities to stay competitive over time and over the evolving, even more competitive landscape. When we organize the data analytics, we also need to consider a few structural aspects. A key thing here is, and do not underestimate this, it's the topic of data governance and management. You need to establish a robust data governance framework to ensure that data accuracy, consistency, security and compliance with the relevant regulations in Europe, in the US, as well as in many other places of the world is established. You need to develop data management policies and procedures, including about data collection, storage, integration, transformation, and archiving. We need to look at data collection and integration. We need to identify the relevant data sources across the institution, such as for transaction data, customer data, market data, and economic indicators. We need to make sure we implement data integration processes to make sure that the data is gathered from various sources, from internal systems, as well as from external vendors. Key really is also the data quality assurance. Even though it's very difficult to achieve, but you need to make sure that you have your data quality checks to identify and rectify inconsistencies, errors and missing values in the collected data. Regularly monitoring data quality to maintain the accuracy and reliability of your results is essential. Here it's already clear that once you have established your data structure, your data analytics, this is not a static part. This will continuously be evolving. You continuously need to require to update and make sure that the data accuracy and reliability maintains. You need to decide on the right data structure, whether you have data warehouses, data lakes, or use both. You need to design and maintain a centralized repository for storing structured and unstructured data, either through the warehouse or through the data lake approach. There are differences in both, and we will not go in this section here into great detail, but there's a vast area of information that you can access. Ensure the data structure needs to make sure it allows scalability and flexibility to accommodate growing data volumes and new data sources. What is key that you have the right structure in the team as well as skill sets available. You need cross-functional teams that include data scientists, data engineers, domain experts, as well as business analysts. You need to make sure that there's really a good understanding of the statistical methods, but also of the business reality. You ensure that your team possesses the necessary technical skills to extract insights from the data. Do not forget about data security and privacy. You need to have stringent security measures to protect sensitive financial data and personally identifiable information. You need to comply with the relevant data privacy regulations and consider the anonymization of techniques when working with sensitive data. Obviously, collaboration and communication is essential. You need to foster collaboration between the different departments within the institution, such as finance, risk management and marketing, as well as IT, to ensure that the insights are shared and used effectively. Obviously, you need to have the necessary buy-in and support from your executives. This is essential because there are roadblocks, there are time constraints, and you need to have that buy-in and support from your senior management to allocate the resources, the budget, and time to the data analytics initiatives. Training and knowledge sharing. All the data analytics cannot be just the proprietary knowledge of a few people. You need to make sure that training is provided to employees across the organization to enhance data literacy and encourage the adoption of data-driven decision-making, similar like you had 20 years ago, the explanation about how the internet works, or 30 years ago, the way to first look at spreadsheets and word processing programs to help your employees to elevate their skills. You need to design your data analytics architecture with scalability in mind, anticipating the growth of data volume and complexity. Remember that the specific structure and approach may vary based on the size of your financial institution, its the goals, as well as the available resources and regulatory environment. You need to regularly reassess your strategy to adapt to the evolving business needs and the technological advancements. This was just a very quick overview of the data analytics concepts. The overall topic is subject to many trainings and instructional videos. In our team at Q-Lana, we do have data analysts and architects available to support you in that work. In the next section, we will speak about the concepts of risk appetite and relationship pricing. Looking forward to see you in the next section.